So as we have find out noise factor F is equal to Pn0 by Gk T0 Bn. So available noise power output is having a new formula in terms of gain and noise factor. Okay, so this formula you have to remember that with with this formula, which is having noise factor and gain and noise bandwidth, and this is room temperature, it you can watch in detail that the noise power is related with noise factor, gain of the circuit, bandwidth. So all these terms are interrelated. Okay, let us move. Now we have to understood the noise factor in a new terminology that is known as noise figure. F can be interpreted as factor. Factor means just like a P by Q form, by which the amplifier increases the output noise. Whenever we say noise factor, when we say noise factor means what we have to keep in mind that with this noise factor through which the amplifier increases the output noise, since in the receiver there are many amplifiers in the circuitry connected in the receiver. So each amplifier not only increasing the signal power but also increasing the noise power. That's why the noise power has to be considered very much. For if amplifier were noiseless, if we consider that, and actually we have to make such a type of amplifier which would be noiseless. So for considering noiseless amplifier, the output noise would be G, K, T and Bn. G, K, T and Bn means this noise factor will become 1. Noise factor become 1 means signal to noise ratio will become equal to signal to noise ratio at output, means in the input side and at the output side both side are having the same signal to noise ratio, and that's why the F value will become 1. I will derive it later also. Okay, so this terminology you have to keep in mind that if amplifier is noiseless, then output noise will become that this output noise will become G, K, T and B, N. Okay, now let us move to with a new name of noise factor, that is noise figure. And what is noise figure? When we derive the noise factor with a logarithmic scale and indicated as 10 log f, then the unit becomes dB, while the noise factor is a dimensionless quantity. Okay, now we have to move with the derivations for derivations and examples also. I am showing you here two examples that I think you should note it down in your copy and solve this. How we have derived that noise factor in dB? See here, this is the formula. As we know that from the formula of noise factor, the signal to noise ratio output is equal to signal to noise ratio input divided by F. This can be originated from the formula of noise factor. And if in both sides we are taking the logarithmic of both sides, then this will become like this formula: log S by N0 is equal to log S by Ni by F. As we know that log A by B is equal to log A minus log B, so the right side has been converted into this form, and multiply both sides with a magnitude 10, then this will become 10 log S by N output, that is signal to noise ratio at output, is equal to 10 log S by N at input minus 10 log F. Now all the quantities are in decibels. So you have to keep in mind this formula, and if you are keeping this formula, since in both the sides the 10 is multiplied, so if you reject 10 in writing, then also this is having the same unit dB, because both the sides are multiplied with 10. Now what you have to do, you have to take this formula and use it for this example, this mathematical example. The noise figure of an amplifier is 7 dB. Calculate the output signal to noise ratio when the input signal to noise ratio is 35 dB. What you have to do, only you have to put the values in this formula and calculate it. I assume that you will be interested to solve this numerical, and please solve it for betterment of your understanding. Now the next example is taken for a receiver having an antenna whose resistance is 50 ohm. So here I am taking the next example, which is for an antenna whose resistance is 50 ohm. The resistance is 50 ohm and has an equivalent noise resistance of 30 ohm. So the two values have given, and what you have to calculate, you have to calculate receiver's noise figures in decibels and its equivalent noise temperature. Okay, we will generate this formula later, but since the numerical has written here, so you have to keep in mind that you have to use these two formula. Okay, the first formula for noise figure is F is equal to 1 plus equivalent resistance divided by antenna resistance. This formula we will generate later for noise in reactive elements and having networks with reactive elements. Okay, and since the magnitudes are given in the formula, you just put the values and calculate it. And the second that we have to find out, that is equivalent noise temperature. So equivalent noise temperature is having the formula T0, sometimes written as T normal temperature, and its magnitude is always taken as 290 Kelvin, and T0 multiplied with noise figure minus 1. So since noise figure has been calculated, so this value can be put here and equivalent noise temperature can be calculated. So I have given you two for numericals. I request you, I advise you to use these numericals to sharp your mind for better understanding of noise figure, equivalent noise temperature and noise bandwidth concept. Now what we are going to study, we are going to derive the formula that we had just now used in the numerical. Here noise figure and equivalent noise temperature measure the same characteristic. They are interrelated. Noise figure and effective noise temperature, they are interrelated, and they are related with gain, bandwidth and equivalent noise temperature TE. Okay. Now already we have studied the input noise power Ni is equal to K T0B. B is the bandwidth and T0 290 Kelvin that we have taken for the surrounding temperature. Okay. And output noise power for any network. So output noise power will become a sum of amplified noise input. Amplified noise input means the input noise is Ni. When it will be amplified by G, it will become G into Ni. So this complete term will be multiplied with G, and you have to add one more term, that is internally generated noise. This you have to take in account. So when you will add this internally generated noise, that is TE, then you have to put here in place of T0 TE, so it will become K TEB and both will be multiplied with G. So actually the complete noise power will become this N0 is equal to kg